Let's have a look at the problem number 2. Problem number 2. During time tau, maybe I'll number 2. Number 2. During time tau, a point traversed a half of a circle of radius r. Find A. The average value of modulus of velocity. B. The modulus of average vector of velocity. And C. The modulus of average vector of full acceleration if tangential acceleration is constant. Tangential acceleration is constant. We can write this. We can write this in this way. A tau is equal to const. Okay, so part A. It is necessary to find the average value of modulus of velocity. Average value of modulus of velocity. So maybe you have some ideas how to do this. Maybe you can remember something from school about this. No ideas. Okay. Yes. And what then? And dr. I see, but this is the definition of velocity. This is definition of velocity, but now we have to find average velocity. Okay, let's have a look at at the path that was traversed by the point. Point traversed according to the written in my PDF file. A point traversed a half of a circle. So I'll draw this. Half of a circle. And half of a circle. So it is necessary to hide this is the whole path that a point has traversed. It is here, whole path, and the radius is r. The radius is r. The radius is r. And what can we say about average velocity? Average velocity. It means full path, full path divided by full time of motion. So according to the definition, we have to write um, something like delta s divided by delta t. And now we have to substitute something instead of delta s and delta t. So what can we say about delta s and delta t? Delta s, it is whole path that was traversed, and delta t is full time of motion. Yes, it's great. It's great. This is correct. Yes, this is correct. Yes, okay. Okay, this is absolutely right. So we have solved the first part of this problem. It was the first part. Let's proceed to second part, B. Uh, in this part, we have to find the modulus of average vector of velocity. So something like this. Modulus of average vector. So how we do this part? Okay, maybe it is necessary. It is necessary to remember the definition of average velocity. I have told you this definition uh, last last week in Wednesday. I have told you this when we started to learn kinematics. So maybe someone can remember this. Okay, I'll remind this. I'll remind average velocity. Average velocity is equal to delta r divided by delta t. Delta t is the same as here, the same, but delta r, we still have to find. We can also write this in the next way. R2 minus R1 divided by delta t. Divided by delta t. Okay, let's draw one more picture. Let's draw one more picture, and I hope it will help us. It will help us to define or to find this delta r. Delta r is known as is called displacement vector of displacement. So we have to find this vector of displacement. I'll draw another picture. Draw another picture. Okay. Another picture. Maybe will be better to put it here. This is a path that a point has traversed. A path is a half of a circle. Path is a half of a circle. Half of a circle, and x, y, or y, maybe reference point or origin. So can we define vector of displacement? Or can we find R2, R1? R1 is a radius vector of initial position of our point. Initial position. R2 is final position. So can we define where was initial position and where is it is initial final? Yes, okay. Okay, I agree. Initial position. Initial position was in origin. Yes, this is correct. This is correct. So R1 is equal to 0. R1 is equal to 0, and delta R is here. This is delta r. Delta r. So delta r, we can write that delta r is equal to r minus r1, and it is it is equal to r2. R2. It is equal to R2, and maybe we can write this by coordinates and orths. So for this we can see that the direction of delta r is the same as direction of x-axis. So it means that we need only orth I. Only orth I. And we can see, oh, sorry. I need to clean my screen because I want to draw something. I'll remind what orths are. This is orth I and orth J. I, J. I, J. And this distance is equal double r, double radius, because diameter of a circle is always equal to double radius. So according to this picture, we can write that delta r is equal to 2 multiplied by r and multiplied by I vector. Okay then let's find average velocity. Delta r divided by delta t, and it is equal to double r I divided by tau. And we want to find modulus. So modulus of this vector. Modulus of this vector will be equal to modulus double r divided by tau. And it is equal to double r divided by tau. We may not to write modulus because double r divided by tau is positive. Okay, do you have any question about this part of a problem?
Teacher, what is the system of arrangement?
What is what?
This
Ah, it is order of axis. Order of axis. Um, we can remember maybe uh, we can remember if you want to set a reference system, and if you want to define vector in this, for example, in two dimensions, in two dimensions. For example, and if you want to define a a vector a, for example, no, not x, a. So how can we define how can we define this vector in this reference system o x y? We can do it in this way. Uh, let's draw some perpendiculars. Let's draw perpendiculars here. Perpendiculars. I'll draw them with dash lines. With dash lines, and then we can sign these distances as a x, a y. And how can we write this vector? How can we write this vector according to vector algebra? How can we write it? We have to define the direction of axis x and axis y. We have to define the directions of axis, and we can do it by using orths. Like this, I and y, I and y. So according to this picture, uh, we will have a is equal to a x plus so I can write that orth is is a vector that has the same direction as its as axis, coordinate axis. I will write coordinate axis, and Mikhail, and the length of it is equal to 1. Is equal to 1. So it means that length of I is equal to 1, and the length of J is equal to 1. Is equal to 1. So is it clear now?
Yes, teacher.
Okay. Okay. I need to clean my screen. I need to clean my screen because I need some space. I need some space to solve the last part of this problem, because this last part is the most difficult. We have to find the modulus of average vector of full acceleration. So I'll clean the screen. I'll clean the screen. See full acceleration. Full acceleration is necessary to average acceleration. Modulus of average acceleration vector is necessary to be found. So, do you have any ideas? Okay, let's define uh, average value. It means that a average and this angular all crocodile brackets mean average value. And these brackets mean average value. So what do we have? We have change of velocity, delta v vector, divided by change of time, and what is the same? It is equal to v2 minus final value of vector of velocity minus initial value divided by delta t. Divided by delta t. So the problem. Our task is to find v2 and v1, initial and final values of vector of velocity. So how can we do this? Maybe I'll redraw my picture because we need it again. I'll define a reference system in this way. Reference system. Reference system. And it is necessary to hide lower part of my of the circle, lower part of circle. I'll hide it, and let's define velocities. Vector of velocity of material point is always tangential to trajectory line. Vector of velocity is always tangential to trajectory. So at initial position, we have this vector of velocity v1. Okay, and can someone define or draw a vector of velocity in final position? Can someone draw a vector of velocity in final position? So as you can see, I have written this v1, and it is necessary to draw v2. Yes, in this point, okay. Yes, okay. Okay, this is correct. This is correct. This is correct. So we can draw this, or maybe I will change length of the vector, because it may change. For example, like this. For example, like this, v2. Yes. Yes. Okay. Okay. And to write these vectors v1 and v2 by formula, to write this by formula, we have to set orths. I j. We have to set orths. So I and j. I and j. Maybe someone can write a formula to define vector v1 and v2. It is necessary to do in the same way like here. not the same, but similar way. Not zero, because zero is radius vector, but velocity is not zero. Velocity is not zero. We can see velocity here, this arrow. This arrow. This arrow has the same direction of vector y, the same direction. So we can we can write this like we can write this like for example v1 in this way. And what about v2? Okay, but the direction of this vector and this axis, these directions are not the same. Oh, good. This is correct. This is correct. I agree. I agree about this. I agree about this. So, I agree. And now we have to find some connection between v2 and v1. v2 and v1. What is what is written about this in our problem description? It is written that tangential acceleration is constant. So according to description of our problem, a tau is equal to constant. A tau is equal to constant. So maybe we can use this condition that a tau is equal to constant. So now we have to remember the definition of tangential velocity, and we have to remember how to define it with velocity. How to define it with velocity. Okay, I'll remind this. It is the first derivative of velocity by time. This is tangential acceleration. Here, according to the description, we don't know the value of tangential acceleration, but we know that it is constant. It is constant. It is enough. It is enough for us. So let's find our velocity from this. To find velocity as a function of time, we have to solve this ordinary differential equation. And maybe you can remember from mathematical analysis, from calculus that ordinary this is ordinary differential equation of first order, and it has separable variables. So let's separate variables. To separate variables v and t, we have to do something to put all variables v at one side and of one side of equation, and all values t or variables t must be in other side of equations, and it must not to be differentials in denominator. So let's change this. We can write this like it is written here, dt. So are variables separated? Yes, they are separated now. Because v and t on different sides of equation, and we don't have differentials in denominator, and in this case we can integrate this differential equation. So we can write like this. Integral by dv is equal to integral by a tau dt by a tau. And now we have to define integral limits. For lower limits, we need to use initial condition. Initial condition is it means initial time and initial velocity. So I can read initial time. It is not this. There is not initial time in description, so we can define initial time like we want to do this. So let's set it with value 0. Initial time will be 0, but initial velocity, it is written here. Initial velocity is equal to v1. And then then we have to write upper limit. Upper limit. Upper limit here it will be some time t, and in order not to have the same signification in integral limit and in integral function, I'll resign this. Because this and this must be written in different ways. Must be written differently because we cannot use the same letters in integral and in integral limits. And the same situation will be in left side of this equation. Okay, do you have any questions?
No.
Not. Okay. Okay, maybe someone can calculate these integrals. Maybe someone can solve this. Now it is just a mathematical problem. So maybe you can remember. Maybe you can remember the table of integrals. And maybe you can find something that is necessary. I'll show this what I mean. You can use for example, you can use Google. In Google you can write for example table of integrals. And find something that is necessary to us. For example, can you find in Google or to remember how to calculate integral like this? Okay, let's try to find the solution. Let's try to find the solution. Let's try to find the solution. For example, find the solution table of integrals. Like this. Table of integrals. We can see, for example, here. And now, can you see Can you see this? Can you see this? The first integral is all that we need here. So let's use this. Let's use this to solve our problem. It is integrals from table. So we have some ready solutions for basic calculus problems, and we can use these ready solutions. So I'll use it. Okay, let's remember what have we found. So according to the table of integrals, we have x in n plus 1 exponent divided by n plus 1 and plus constant. We will always have this constant because this integral is undefined. So it has no integral limits. This integral has no integral limits, and because of this we have constant here. Okay. According to this, can we solve this? Can we solve this? Maybe someone can remember some maths, can remember math and calculate this integral. No one can. Okay. Okay, I'll give you a tip to how to solve this. It is the same as 1 multiplied by dx. Maybe now yes, that's good. Yes. So we have calculated this integral. Okay, let's go to define integral. Define integral from a to b dx. What will be here? What will be here? Okay, we can use this solution that is written here. We can use this, and we can write according to Newton-Leibniz formula. Newton-Leibniz formula we can use. And according to this, we have B minus A. B minus A. Can you remember this? Okay, this is Newton-Leibniz formula. The Newton-Leibniz formula for calculation of defined integrals. And now we will use it. We will use it in our problem. I'll clean some space. I'll clean some space. Clean some space because I need it, and I'll use this. Okay, can we use this to calculate this integral? Let's do this. Okay, but it is not x. It is not x. It is v. Yes, it is v with with this sign. With this sign on it. Okay. Okay, and what can we we say about this? About right side. Now we have to take into account. That a tau is constant value. A tau is a constant value. So yes, it is from 0 to t. No, no. We have to remember some properties of integrals. Some properties of integrals. If we have constant, how to say this, not add-on, constant coefficient. If we have constant coefficient in integral function, we can do like this. I'll show here. If we have maybe, okay, I'll clean this. integral from 0 to t a tau d t dt with sign on it, okay, and let's take into account that a tau is equal to constant. If it is constant, we can write this outside the integral. Yes, it is. It is. No, it is not. It is not. But it is. It is close. It is close to solution. It is close to solution. But we still need to use integral limits. We still have to use integral limits, but it is good idea. So I mean that we can write constant outside of integral. Outside of integral. And what can we do now? It is a tau t from 0 to t, and it is equal to a tau t minus 0, a tau t. Okay, do you have any questions? No questions. Okay. So as we have found that right side is equal to a tau t. A tau t, and the right side is v minus v1, v minus v1, and according to this, we can write v minus v1 is equal to a tau t, is equal to a tau t, and now we have v is equal to v1 plus a tau t. Okay, do you have any questions about this? This formula defines the dependence of velocity on time. Dependence of velocity on time. So we have just found this dependence. So according to this formula, according to this formula, we can write that v2 is equal to v when t. Okay, I will not, because it may be some misunderstanding. v1 plus a tau tau. So because tau is a final moment of motion according to the description in my PDF file. Okay, so we can use this. We have found that this, and we have found this. I need some more space. I need some more space on my screen. I need some more space, and I will clean my screen. I will clean my screen, and I'll clean my screen. So let's make substitution. So let's use, I'll use this definition of average acceleration. I will use this definition, and I'll use formulas. I'll use formulas for velocity. Use formulas. Oh, minus v1 plus a tau yod minus v1 yod divided by tau, and we can simplify this. It will result minus 2v1 plus a tau yod. So it is simplified. It was simplified. Okay. Okay, do you have any questions about this? No questions. Okay. If we have no questions, we can continue. We can continue our solution, because according to the description, we have to find modulus of average acceleration. So it will be modulus of minus v1 plus 8 tau multiplied by tau divided by tau. And it is equal to v1 plus is numerator positive or negative? I think it is positive. It is positive because if it is negative, according to this, if it is negative according to this formula, a point will not get final position if it is negative. So velocity v2 and this part of formula cannot be negative. So it is definitely positive, and I may not to write modulus double v1 plus a tau divided by tau. So we have found some formula for a modulus of average acceleration. But we still have no answer. Why? Because we don't have the value of initial velocity v1, and we don't have the value of tangential acceleration. All we know that tangential acceleration is constant, but we don't have its value. We don't know this. So how can we, what can we do in this situation? I have cleaned something that it is necessary now. I have cleaned. Maybe I'll remind this. We have found that v is equal to v1 plus a tau t, and v1 is equal to v is equal to v1 plus a tau t. We will need this, and we have found it some time ago, a few minutes ago. Okay, and this is not necessary. This is not necessary now. This is not necessary. I can clean this, and I'll it. Let's use this. Okay, can you remember the definition The definition of velocity, or the definition of its modulus. We can define velocity as a first derivative from of path by time. So let's use this. Uh, can you remember how to separate variables in this differential equation? Maybe not separate. Let's make a substitution before. Let's make substitution. So we have ds divided by dt is equal v1 plus a tau t. Okay, so we have ordinary differential equation again, and we have to find the dependence of path, the dependence of path on time from this equation. In order to do this, we have to separate variables. Can you remember how to separate variables? You need to remember how we solve this. Is equal to v1 plus a tau t. No, sorry. We had this, and as you can remember, we multiplied left and right sides of equation by dt, and we have obtained this. I hope you have written this and you can remember. Let's do it. Let's do the same with this. Let's do the same with this. Okay, let's do the same with this. ds to separate variables. v1 plus a tau t, multiplied by differential of time. Okay, are variables separated? Yes, they are separated now. They are separated, and because of they are separated, we can integrate these differential equations. We can integrate it, so we can write ds is equal to integral v1 plus a tau t dt. dt. T. Okay, now we have to set integral limits. Integral limits according to initial condition. Can someone set integral limits? Before calculating integral, we have to set integral limits. Integral limits. I mean numbers here, here, and here. I mean these numbers. Okay, so here will be initial time. Oh, yes, yes, that was good. That was good. Yes, because the initial path was equal to 0. Was equal to 0. And what about the final path? Initial times was also 0. Yes, I agree. This is final. This is for final path. Final path was PR. Yes, and it is tau. Okay, okay, okay. That's great. That's great. And we can calculate these integrals. We have no much time, so I'll do it myself. From 0 to PR ds, it will result as PR, and it will result PR. And what about this? From 0 to tau, V1 plus a tau multiplied by t dt. We have linear integral of linear combination. We can write like this: from 0 to tau dt plus a tau integral 0 tau t dt, and we can write v1 t 0 tau and plus a tau t squared from 0 to tau, and finally we have v1 tau plus a tau squared divided by 2. Okay, is it clear? Do you have any questions?
No.
No. Okay. Okay. So I will clean some space that I need to. I will clean some space. I'll clean some space and clean some space. Here I don't need this. I don't need this, so I'll clear it. I'll clean it. I'll clean. Oh, I have cleaned something. I have cleaned something that that I need. I'll rewrite this. It will be easier to rewrite this. There was differential equation. There was differential equation, and there was formula like this. I have cleaned this, but we still need this formula. V1 plus a tau t. Yeah, and let's make substitution. Let's use this PR is equal to V1 tau plus V1 tau plus a tau squared and we can rewrite this in the next way. Like this. V1 plus a no V1 sorry, this is a mistake. V1 plus a tau. Okay, this is the same. And what we can get from this? From this we can get that double V1 plus yes.
Teacher, I don't understand this part to this part.
Because let's remember that integral like this has a solution n plus 1.
Okay, thank you, teacher. I understand.
Okay. Okay, so a tau is equal to double p r divided by tau. Okay, and it is what we need. We can use this here. We can use this here, and we have got answer. Okay, do you have any questions? Do you have any questions? No questions. Okay, and your first home task, will be exercise number 1. Exercise number 1 from PDF file that I have sent to our Telegram channel. Exercise number 1. It is necessary. It is necessary to do, and send it to me. Send it to me. If something is unclear, you can write to me. You can write to me and ask me what to do. Okay. Okay. So we have the end. We have the end of our lesson. Okay. We have the end of our lesson. And thank you for your attention. I hope we will meet next week. Next week.
Okay, teacher.
Thank you, teacher. Have a nice day.